Okay, for your test review, let's dive in. And looking at question number 1, find the indicated term for the sequence. In this case, we're indicated the 12th term, which means that everywhere we see n, we're just going to put 12 in its place. So 12 will go here, which means 12 will go here, and 12 will go there. Okay, it's no different than your Algebra 1 stuff going, hey, x equals 7. Then everywhere you saw the x, you put a 7 in. It's the same situation here. Everywhere you see n, you put in 12. So the 12th term is equal to 5 times 12 minus 4 times 4 times 12 plus 3. This could end up being a fairly large number. I'm going to have 60 minus 4 times 48 plus 3, which is 56 times 51. 56 times 51 is 2,856. So there you go. That's all there is to it. If anytime you're asked to find the indicated term, just simply substitute whatever that term is in for all the n's, and you're off and running. Okay, on this guy, we want to find the 15th term of the arithmetic sequence, and this is a critical thing right here, the arithmetic sequence, because what they're telling us with this phrase is that we're adding or subtracting a specific number. Okay, and so what we have to do is just figure out what it is that we're subtracting. So let's just go -4. Well, let's take where we stop minus where we started, and this will tell us what the difference is between each term. So I'm just gonna punch it into a calculator real quick. So it's going to be -19 fifths plus 4. And that's 1/5. This is 1/5. Okay, so we're changing by 1/5 each time. I don't want to have to figure out all of these little guys all the way out to the 15th term. That's a lot of work. So if I can figure out a pattern that represents this and gives me an explicit form, like question 1, then all I have to do is substitute in the 15. So my first term is 4. So and we know that we're going to have 1/5. So what I need is something along the lines of my first term plus the difference that I'm looking at, which is in this case is going to be the 1/5. All right, and then I'm going to multiply by the number of terms that I'm interested in. So when I do this, what do I get? Well, I need to be able to get on that first term a -4. Okay, so if I put the -4 in here and add 1/5 times 1, I end up with not -4. So because it's going to be -1/5 plus 1, that's the first term. That's not going to work. So what I can do is change my formula here by maybe saying the n-1 term. So then when I look at that very first term, I can take -4, this is the first term, plus 1/5 times 1 minus 1, which is 0. And that's actually going to work for this guy because -4 is 4. And then when I put a 2 in here, that would be 2 minus 1, so -4 plus 1/5, which gets me the -19 fifths. So to find the 15th term, I use this formula right here. And you can also use your calculator and help yourself out as well. So this is going to be -4 plus 1/5 times 15 minus 1. And I'm just going to punch that into my calculator real quick. And I get -6/5. And really that's all there is to it. You want to try and identify an explicit formula to handle any sort of sequence situation. And in this case, our explicit formula is this guy right here. He's our explicit formula that we're going to use. All right, now we want to find the indicated term for the geometric sequence. Geometric means that we're now going to multiply. So, when we look at this, particular problem, the key word right here for us is geometric sequence, which just means that we're going to multiply together to get to the next term. So let's do where we stop divided by where we start, and that will give us our common ratio, which in this case is 4. So now we just need to figure out what we can do to get a 4 using that explicit formula. So I have -3, and it's going to be -3 times 4 to what power equals -3. And if I can put a 0 up here, and we're looking at that first term, -3 times 0, -3 times 4 to the 0 power is -3 times 1, which is 4. And so to get the next term, I would just need to multiply -3 times 4. Well, that's -12. So my explicit formula is actually going to be this guy right here. And if I want to know the 14th power of that, then everywhere I see n, I put in 14. So if my explicit formula is an equals -3 times 4 to the n minus 1, then I put 14 everywhere, and the 14th term is equal to -3 times 4 to the 14th minus 1 power. This is liable to be a fairly large number. That's going to be 4 to the 13th power. And I get -2, 0, 1, 3, 2, 6, 5, 9, 2. So adding some commas, and there you go. There's your answer for question number 3.